All right, part 5 of 6 for Unit 1. We are almost done with Unit 1. This is all about states of matter as well as phase changes. States of matter is really simple. This is elementary, so we're going to go through that really quick and spend much more time talking about phase changes. So for states of matter, you should know the three states of matter: solid, liquid, and gas. Okay? Solids have a definite shape and a definite volume. Okay? Again, solids, they don't take the shape of their container. They have a certain shape and they keep that shape. Same for the volume. Liquids, on the other hand, have a definite volume. So each of these beakers, well, that's a flask, and this is a graduated cylinder, there's 100 milliliters of liquid in each of these. So it has a definite volume. The volume does not change, but the shape does. There is no definite shape. Liquids take the shape of whatever container they're in. Gases have no definite shape and no definite volume, meaning they take the same volume as their container and they take the same shape as the container. So if the volume of the container changes, so does the volume of the gas. If the shape of the container changes, so does the shape of the gas. Now here's where it gets a little bit harder. You guys really haven't talked about this before. Let me see if I can zoom out real quick. View, zoom out. That way I'm just not blocked. There we go. So what makes a solid, a liquid, and a gas? Why is something a solid? Why is something a liquid? Why is something a gas? And it all has to do with what are called attractive forces, specifically the universal law of gravitation. And the universal law of gravitation tells us that if anything has mass, all matter, as long as it has mass, everything is attracted to one another. And the closer you are and the bigger you are, the stronger that attraction. So for example, my PlayStation 4 controller has mass. Okay? Therefore, this controller is pulling everything in the universe towards it. Everything in the universe is getting pulled towards this controller. And this controller is getting pulled towards everything out in the universe that has mass. I have mass. You have mass. Guess what? If I'm just going to use me as an example, since I have mass, everything in the universe is attracted and getting pulled towards me. And I'm getting pulled and attracted towards everything else in the universe. So, with that being said, why is a solid a solid? Well, solid particles are very close together. And since they're so very close together, there's a strong attraction between the particles. So that keeps them their definite shape and volume. A liquid, on the other hand, are attracted close together, but they're weak. The attraction's weak enough that the particles can flow past one another. So it allows the flowing to occur. A gas, particles are very, very weak. There's a very weak attraction because the particles are very far apart. Because again, the closer you are, the stronger that attraction. Solid particles are very, very close together, so there's a strong attraction. Liquid particles are close, but far enough that they can flow past. And gas particles are very, very far apart, so they have a very weak attraction. Phase changes. Zoom in here. So again, phase changes are like states of matter. You probably should know most of these. But what's really important, let's see if I'm not in the way here. Oh well. Oh well. A phase change is when one material goes from one state of matter to another. So again, you go from a solid to a liquid to a gas to a solid, whatever. Here's the most important part though. The temperature of a substance does not change. Do you understand me? During a phase change, I repeat that, during the phase change, the temperature will not change. So, for example, water will both freeze and melt at the exact same time at 32 degrees Fahrenheit or 0 degrees Celsius. At 0 degrees Celsius, so if you take up a piece of ice, okay, and it starts to melt, that ice has a temperature of 0 degrees, and it's going to forever stay 0 degrees until all the ice has melted. Basically, what happens is the following. We're going to look down at this diagram. There we go. Probably have to move my picture again. Well, it's good enough. So let's say we have ice. What happens is ice, as you start to raise the temperature, why? Because particles are moving faster. We'll talk about that in the next part called the kinetic molecular theory. The particles move faster, which causes a rise in temperature. But once we hit this right here, this is 0 degrees Celsius if it's water. Freezing and melting occurs at the exact same time. Well, what determines if it freezes or melts? It depends on the energy. If energy is being added, then basically that heat energy is going to break apart the bonds, the solid bonds, attractive force bonds, and cause those particles to move a little bit farther apart. But it's still going to be 0 degrees Celsius until all those particle bonds have been broken. Okay? At that point, when all the ice turns into a liquid, then it's all liquid water. At that point, as the particles move faster and faster, the temperature rises again. So again, if you have ice and you want to turn it into a liquid, when that ice is melting, that ice will forever stay 0 degrees Celsius until all the ice is melted. Then, when it gets to the point where it needs to boil, so water boils at 100 degrees Celsius. When water is boiling in a pot, it does not matter how hot the stove is. Does not matter. As long as it's hot enough to boil the water, at least. The stove could be 500 degrees Celsius. It could be 300 degrees Celsius. The point is, the water that's in the pot that's boiling is forever 100 degrees Celsius until all the water, liquid water, boils and turns into a gas. So, as more heat is added into the pot of water, all that boiling water will forever stay 100 degrees until all that water gets turned into a gas, and those gas particles start moving faster again. Then the temperature will rise for the gas. Same thing if it cools down. So again, if gas particles start to cool down, it starts to condense. But again, it condenses at 100 degrees. What causes it to condense? It's going to lose heat energy. It's going to give off heat energy, which causes it to cool down. And then the attractive forces start to work, and that brings them closer together. It turns into a liquid. Then when it's all liquid, you can cool it down until it gets to 0 degrees Celsius. And then again, then it's going to start to release heat energy to the surroundings, and those particles are going to have stronger and stronger attractive forces, but it's going to stay 0 degrees Celsius until all that liquid turns into solid ice. And then it can get colder and colder and colder and colder. So we're going to talk more about that in class, but the most important thing to remember is during a phase change, the temperature does not change. Now, what causes the change, as I kind of mentioned earlier? Well, it deals with how much energy is either being taken in, being absorbed, or released. When energy is being absorbed, that is called endothermic. It takes in, like endo, in, take in. So it's going to feel cold. For example, when you hold an ice cube in your hand, the ice cube is absorbing your heat, so it feels cold to you because it's stealing your heat. Exothermic, exo, exit, to give off. This is when heat is being released, like a fire. A fire is giving off a lot of heat, so it feels hot to you because the fire is giving off heat and you're absorbing the heat. So if we look here, when things melt, okay, heat's being added. When things freeze, it's releasing its heat. So water, when water turns to ice, the water is releasing, it's exothermic, it's releasing its heat and changing into ice. When ice melts, it's absorbing heat, it's endothermic at that point, and that way, since it's absorbing heat, it can turn into a liquid. Phase changes. You should know the phase changes. I'll just use this diagram to show. But when you go from a solid to a liquid, that's called melting. Liquids into solids is called freezing. Again, you should know this. Liquids into gases is called vaporization, sometimes evaporation. When you go from a gas to a liquid, that's called condensing or condensation. The ones people don't really remember too well is when you go from a solid to a gas. That's called sublimation. Dry ice does this. If you go from gas straight to a solid, that's called deposition. I've never seen anything go from straight from a gas to a solid. I know it can happen. I'm sure you can look it up on YouTube. But those are the main phase changes. All right. So we have one more unit to go, and we are not one more unit, one more part to go, and we are done with this unit. I'm also going to, right after this video, have a link so you can watch this music video from one of my favorite teachers from many years ago who sings a song about the phase changes that kind of summarizes what I talked about here.